Hi, and welcome to Concept Based. I'm John Hepworth, and we are doing a Year 11 advanced topic. We are doing trigonometric identities and equations today. We're specifically looking at the outcome, solve problems involving trig equations, including those that reduce to quadratic equations. So we're going to focus on the quadratic equation part of trig equations today. And I just want to note that mathematics is cumulative. You know, you learn something and then we add something on top of that, and then we add something on top of that, and so on, up to the point where here you are in stage 6 doing year 11 advanced mathematics. And so in year 10, this relates to the equation C section in the path course, solve quadratic equations using a variety of methods. Now, you probably got taught that back in year 10, and then you haven't revisited it, probably. You may be in a school where you do yearly exams, and it was in a yearly exam, so you revisited it back in term 4 last year. But maybe you're not. Maybe you're in a school that just does topic tests and then you move on. And it's so important that the algebra and equations part of year 9 and year 10 are continuously revisited over your studies of stage 6, because if you forget any part of them, then they pop up in these more complex sections of mathematics. So here we are in trigonometry solving equations, and a stage 5 year 10 concept of quadratic equations comes up. And if you're not across that's a hard word today, quadratic equations completely, and I mean all forms, even quadratic equation, quadratic formula, completing the square, perfect squares, anything, difference of two squares, any type of quadratic equation that can appear, you have to be 100% across it. Not, oh, I got 80% in my equations test, so I'm fine. Well, no, because then what if this is one of those 20% of those questions that you got wrong in that test that now has a trig part, and in your stage 6 outcomes, you can't demonstrate that you understand the trig bit because you're struggling with the algebra part from year 10. Okay, so that's pretty long-winded, but I'm just trying to, enforce it's cumulative. You personally need to take responsibility for your understanding for stage 5 content and go back and revise it. Now, when I say go back and revise it, it's so much easier today. Today, you can just go and grab the outcome out of the syllabus, dump it into Copilot or ChatGPT or whatever you're using, and just say, give me 5 questions with a variety of 5 of these questions, and it will give you a bunch. Go and solve them. Now give me the work solutions. See if you did it correctly, and it will tell you if you did or didn't. So it can help you so easily to do revision. If you are thinking to yourself, oh, my teacher never goes back over the stuff I never learned, that's not a mindset that's going to help you get band 5, band 6 outcomes in the HSC. You need to take responsibility for that. Okay, so I'll now step down off my soapbox and we'll do this question. Now, this question, I would typically break into 2 types of students that would attack this question. If you are the type of student who is comfortable with all of the trig identities, there's one way you can solve this. And if you're a student that really struggles with all of the trig identities, I would recommend a different way. And what are those 2 different ways? So in this question, cot squared x appears. If you're a student that is comfortable with trig identities, I would use cot squared x and turn it into something else, such as the cosec x that's in the question. If you're a student that is not comfortable with trig identities, I might recommend to you to reduce it down to causes and sines, and then just further reduce it down to sine, and then just do it all in sine. It all works out exactly the same. It's completely fine to do it either way. In this video, I'm going to do it the slightly more advanced way, the understanding the trig identities way, because it really is the goal that we're looking for. However, if you ever get stuck and you can't solve a question, first of all, I recommend in an exam moving on and just starring it and coming back to it if you have time. But if you then do come back to it, using the approach of just reducing everything down to a sine function or a cos function and try and solving it that way. All right, but let's go ahead and do this in the more skilled way today, which is using any of the trig identities. Okay, so when I say using any of the trig identities, what I'm talking about is your reference sheet. And your reference sheet, I can pull that up, has this on it. for trig identities for advanced mathematics. So the one that's important in this one is that bottom one, cos squared x plus sine squared x equals 1. So you need to be across the fact that you can manipulate that. And what do I mean manipulate that? Okay, well, let's have a look. So cos squared x plus sine squared x equals 1. When I say you can manipulate that is you can transform this into any type of trig identity that you want. So if you wanted sines in this one, sine squared, it's already there. You can make it the subject. If you wanted cos squared, it's already there. You can make it the subject. But in this one, I want cot squared. Now, cot is cos over sine. Once again, on your reference sheet, right? It's telling you there, cos over sine is cot. So we need to get cos over sine in this cos squared one. So we're going to divide by sine squared because that makes this term right here cot squared x. Okay, we've created that. And then this one's going to be divided by sine squared x because we divide the whole left-hand side. And then this one's going to be divided by sine squared x. So just learning that you're given a formula and then you can manipulate that formula into what works for you is a huge step in trigonometry. If you realize that in advanced mathematics, that's fantastic. Extension students, you should definitely be completely across this. All right, so now we get this cot squared x plus, so sine squared x over sine squared x is just 1, and 1 over sine squared x is cosec x. Now I'm writing CSC because that's how it works in the equation editor in OneNote. It's also how it works in Desmos. So you might need to be comfortable with seeing cosec as CSC at times because it's easier to write. Now we haven't made cot squared the subject, so we're going to minus 1, and we get cot squared x equals cosec x minus 1. Now we can go ahead and make the substitution. So that is the trig part. That's the entire trig part of this question done, right? So it's not a lot. It's just understanding how to manipulate an identity to get it in the form that makes it really easy for you to substitute. All right, so let's go and take out the working that we did to get to that point. And let's go and grab this substitution that we've got. So I'll grab this and we'll bring this up the top here because we're going to use that. Okay, so let's go and substitute that into our equation. So we're replacing cot squared with, oh my goodness, I'd made an error in that substitution. It was cosec squared x. Go back in the video, see where I wrote cosec x. It's cosec squared x because it was 1 over sine squared x. My apologies. I won't edit the video. I've caught that in time. We'll just go with this. So now cot squared is getting replaced by cosec squared x minus 1 minus, back in the equation, 2 cosec x plus 2 equals 0. And now I'm going into year 10 or even year 9 and year 8 algebra, and the rest of it is just algebra from stage 5. Okay, so we shouldn't be making mistakes in this bit. Well, I shouldn't say all of it is. We get to the end and it goes back into trig. All right, so then we have 5 cosec squared x minus 5 minus 2 cosec x plus 2 equals 0. These two are just terms that we can put together, and we get 5 cosec squared x minus 2 cosec x minus 5 plus 2 is minus 3 equals 0. And we've arrived at a point where we have a quadratic equation, but the variable in the quadratic equation is not x, it's cosec x. And what do I mean by that? Well, it's just cosec x here, Mr. Hepworth. What are you talking about? Well, it's cosec x there, but it's cosec squared x there. Just like in quadratics, we have 5x squared minus 2x minus 3. Here we've got 5 cosec squared x minus 2 cosec x minus 3. So it's just like having the x variable, except it's cosec x. And so we're just going to deal with this quadratic with that being the case. Now, if you're the sort of student that would substitute m in and do it in terms of m squared minus 2m, minus 3 and solve it for m and then sub back in, you can. However, when you're doing a substitution, you're taking an extra step. You can just do it in terms of the trig identity. So I'm just going to do that. Okay, so Now I'm have a non-monic quadratic. So are you fine with your stage 5 quadratics? If it's non-monic, we are looking for numbers that multiply to give the first term 5 times the last -3, so times in to give -15, and adding to give the middle term -2. Things that time to give 15 are 5 and 3. One of them has to be negative. The negative has to be on the 5 so that we get -2. So we're finding -5 and +3 are our factors that we're after. So we go and use those and break up the middle so that we can do factor by pairs in this quadratic. -5 cosec x plus 3 cosec x, running out of room on this page, -3 equals 0. Made it. All right, so now we can group by pairs and we can take 5 cosec x out and be left with cosec x minus 1. And we can take a 3 out and be left with cosec x minus 1 equals 0. And because we built it in this particular way, we now group by pairs. It's always going to work if we do it correctly. And we get 5 cosec x plus 3 cosec x minus 1 equals 0. Okay, now just like in solving quadratic equations, where you then have to go and solve each of these brackets because of the null factor theorem, we do that in the trig. So we're going to move back into trig ideas now. So we've got two equations. We've got 5 cosec x plus 3 equals 0. And we're going to make cosec x the subject. So cosec x equals -3 on 5. And I'll talk about that in a sec. And then I'll do the other equation. Cosec x minus 1 equals 0. So cosec x equals 1. All right, so these are our two equations that we're using to get all of our solutions for our trig stuff. So when we do solve these, you can be thinking just in terms of what does cosec have to be to make these numbers work, or you can just substitute in what cosec is, which is 1 on sine, and then turn it back over and then just do it in terms of sine. I'll do that here. It's not as advanced. Some people can work in terms of cosec, but I'll do it just to make it a little bit easier. So just that first equation is 1 over sine x equals -3 on 5, which if we then do the reciprocal, we'll get sine x equals 5 on -3. And now if we think about this equation, when does sine x equal a number greater than 1 or less than -1? Never. It never does, because you can never have the opposite side greater than the hypotenuse. So this one actually has no solutions out of this bit. So we can't use this bit of this equation. Okay, so then we'll look at the other equation. So the other equation we had up here, cosec x equals 1. So we'll write that as 1 over sine x equals 1, which if we find the reciprocal, we get sine x equals 1, because 1 over 1 is 1. And then we can solve that. Okay, now the way I solve this, when I have things that are exactly at 1, I think more of the function rather than the unit circle. So I don't do this when it has 1 values. I think of what sine x looks like, and it looks like this. And I think to myself, when does it equal 1? And I know it equals 1 at pi on 2. So I do that part of the solution in my head via the graph. So again, I've said this in many videos in the past, you should be thinking of trig in 3 ways. You should be thinking of trig in terms of triangles. Now this is a weird triangle where opposite over hypotenuse is the same size. So it's like a right angle triangle with no size at the adjacent. You should be thinking of it as the graph, and you should be thinking of it as a unit circle as well. If you can get all 3 of those together, you'll be far better at trig. So in this case, x equals pi on 2. And that's inside the domain that we're looking at from 0 to 2 pi. There are no other times that equal that. And that's our solution. So in summary, this is the advanced way. You have to be able to manipulate the identities into terms of cot, cosec, and sec. If you struggle with that, you can do it via the less advanced ways, getting it down to sine squared and doing it. You must be across your year 10 content because you have to be able to do quadratic equations with no problems. Just do the algebra of quadratic equations. And then the last bit is you have to be able to do trig equations correctly because you've got to go and actually find your final solutions. So doing that with unit circles, graphs, and triangles is what you need. Hopefully that helps you solve trig equations reducible to quadratics.